Good afternoon, YouTube. So I was thinking of not doing a YouTube today, and here I am. We're going to take a snippet off of a topic that isn't covered very often, but it does appear on a number of tests, and when it does, it just throws a lot of people for a loop. Um, I actually don't know the name of it. I actually haven't played with this topic myself for a while, so I'm calling it the unknown symbolic digit problem. At some point, I'm going to look this up and find out what it's called. It's probably called a multitude of things, probably including what I just named it. Exactly what am I talking about here? All right, so let me make sure the stream's going. Yeah, the stream seems to be all right. So we're going to spend about 15 minutes going through some of these, maybe longer. I'm going to try to shoot for 2 problems, maybe even just 1. Depends how far we get with the first one or not. So let me kind of show you what I'm talking about here. Whoops, give me 1 second. I just knocked a cup or something over. Let me use a different piece of paper. Actually, it's all over my pen now too. So if we have 1 AA7, okay, times 5, and we get 5A35 as our answer. So the question is, what is A? Now, some of these are easy to figure out, and some are hard, and some require algebra, and some don't. So for starters, a bunch of you are probably going, what? What the heck is this? Right? How can we do this? It turns out you can do it. So a test-taking skill you have already is to just brute force. In this case, you don't have any answers. So related to brute forcing is just start trying stuff. So there's certain numerical characteristics that are going to be coming out through this. One is that every digit we use can only be from 0 to 9. There's no other choice. All right? We already know the 1, the 7, and the 5. So the question is, what is A? Well, A has to be 0 through 9. So a normal strategy might be to pick one and just start working with it. And depending on the answer, you can move up and down. So based on that, since this kind of, you're going back and forth, it might be worth trying to start from 5. So if A was 5, right? If you said A equals 5, then that means we're talking about 1557 times 5 equals 5535. So what we're going to do is plug it in. We're going to start doing those calculations. So if we 1557 times 5, right? And there's only being one level here. So 7 times 5 is 35.3. 5 times 5 is 25, carried it to 7. 2, 27 again, 2. So we get this number. So that's too high. All right, so then we might try 3. We might get 1337 times 5 now. Because 5 was way above 5,000, right? If it was lower, we would bump A up, so it's higher. So we're going to jiggle this back and forth. We get 735, 15, 18, 1, 15, 16, 1, and 6. So we moved in the right direction. We're getting closer, right? So let's go maybe 2 down again. So we might have 1227 times 5. So we're going to get 35, 3, 10, 11, 12, 13, 1, 10, 11, 1, 6. We're getting creeping closer. So we're at 2 already. So we have to try 1, 1, 1, 7 times 5. We get 5 carried to 3, 8, 5, 5. We're very close. We're very close. But we look at this and say, wait, the only other thing we can do now is try 0, right? So if we get 1007 times 5, we get 5 carried to 3, 0. So that's 3, 0, 5. that matches the original pattern. Right, can I get the both of these on the screen at the same time? See, we have 0, 0, 0, these three here. And everything else is the same. So on a problem like this, now that you kind of getting a feel for what's being talked about in this problem, so you can brute force it. It turned out this was one of the easier ones to do this brute forcing and educated guessing problem. And it's still important. It's still showing you, demonstrating your mathematical savvy, and that you could at least approach it that way. Because some kids might just give up completely and not even know where to start, not realizing they should just be trying random numbers. In this case, we tried the random number from the middle, the 5. If 5 produced a number that was less than the 5, 835, we would have moved up. In this case, it was too high, so we moved down. So you want to do, this is called the binary search, where in this many categories of problems where if you have two extremes, okay, if you start from this extreme, it might take a long time to process everything to come to here. Similarly, if you start here, it might take a long time to process whatever's in there. And it could be the digits from 0 to 9 here in this case. Okay, so what I did was I started in the middle, started at the midpoint, and you have to make an educated guess which way to go. I guessed it was here, so what we want to do is try that. If it doesn't work, depending on the context of the problem, we're either going to go here or we're going to go over here. And when we go to either one of those, depending on our answer, we might take a second midpoint between the end and the midpoint, or this end and this midpoint. Okay, it depends what kind of answer we got with the context of the problem again. And we can make smart, educated guesses back and forth and back and forth. But once we're here and we realize we should be on this side, we ruled all these out. And vice versa. If we realize we should be on this side, then we can rule all these out. And this notion of binary searching comes in a lot of cases. I think I presented this scenario. There's some tests that have multiple choice in A, B, C, D, E. And some of those same tests put the answers in numeric order. So they would not have 99, minus 99, 54, 23. They would put these in order. So for A, they would put minus 99. Then they would put 23. Then they would put 55. Then they would put 99. So these are in order. So you might, if you don't have an inkling, you might pick the middle number, which is C, because it's the midpoint of this ordered list. Okay, some tests don't have 5 choices, and some tests don't order the numbers. But you can still do that yourself. Even if there's only 4 choices or 3 choices, you can still pick the middle choice and do this binary searching back and forth between the answers. So anyway, in this case, if you started with, say, 55, and let me give you another 100, because then that's 5 numbers. If you started with 55, depending on the question, you're going to decide to do 23 and 99 maybe, or 99 and 100, depending on the answer. And it's a faster way to do stuff too. Okay? This is in cases where you don't know the answer, or there's questions where you actually do have to test the numbers. But it still means you need to know what's going on. In other words, the question could involve the absolute value of x, where these answers here are x. Well, if you don't know what x means or absolute value means, then you're up the creek, right? So anyway, there's that kind of a thing. So what I'm going to do is rewrite the problem here, and we're going to solve this algebraically. I might just stick with this one problem, and we'll do a part 2 to this at some other point. Okay, times 5 equals 1a 35. 5a 35. All right. So we want to look at this as if it's a normal math problem, and it touches into do you really understand what you've been doing when you do a multiplication, especially involving multiple digits. Okay. So if we rip this apart, okay, there's a couple steps here. This is 1,000 times 5. That's what that digit here means. That's in the thousands place. Unit, 10, 100,000. So that's 1,000 being multiplied by 5. Okay? Okay, I'm going to skip the next 2 things for a second. We also have, did I write the problem right? No, I didn't write it right. It was that. 1A is 7. So we also have 7 times 5. We could break it down like this. But this is going to be all added up together. So what we really have is 1,000 plus 7 times 5, right? Or 1,000, 7 times 5. So what I took is what we know, the 1,007 times 5. All right? So that's going to be our one thing. 1,007 times 5 is one of the things. So the question is, how do we do the same thing with the A's? Well, what I did was I took the unit position and multiplied by its place value. So it was 1 times 1,000, and this is the unit, this 7 times just 1 7 times 5. This become 1,000 times 5, 7 times 5. So this is 100A, right? Ones, tens, hundreds. This is 100A times 5. And I get, guys, that anybody watching this, or if you're doing the replay, that this is oddly familiar, but also totally unfamiliar at the same time. So if you're not understanding this, it's fine. And then the A here, the second A, it's not the same value. It might be the same value if I have 1, 2, 3, 4, okay? This is 200, it's not 2. This is 30, it's not 3, okay? I like to say, what's this digit? The digit's 3, but its value is 30. This is 1,234. That's why we say it that way. It's 1,234. That's what that number is. So what we're doing is up here, we're ripping it backwards. We're doing reverse place position. So this means there's 1,000 ones, or 1,000. Well, this means there's 100 A's. Okay? So we have 100 A's times 5, and this means there's 10 A's. So we have 10A times 5. So just like we combined the 1,000 and the 7 to become 1,007, okay? We're going to get 110 A's times 5. All right? And that's the two parts of everything we're adding. We're going to do 1,000 times 7 times 5 plus 110 A times 5. So that's plus 110 A times 5. All right? And that's what this up here means. It means those two things. The setting up of the problem means this. So now the question is, what does the answer mean? Well, it's 5,000, right? The same as we ripped this apart. It's 5,800, I'm not saying 8, 835. So let's split it in part the same way with the other. So it's 5,035, right? That's it. It's the whole number. Plus 100A. All right? So what we did was the multiplication of these two things equals that. So this, which is the top, equals the bottom. So let's write that out in a more normal form. So we have 1,007 times 5 plus 110A times 5 equals 5035 plus 100A. And now we just have normal algebra. So we can do the distributive property with the 5 if we want, or we could just multiply things out. So this is 5035, right? This is 110A times 5 is 550A. 550A. And then this stays the same. 5035 plus 100A. So now we took this, we're throwing it out the window, and now we're down to a regular solving an algebraic equation. All right? So what we try to do is get the A's by itself. So we're going to subtract the constant from both sides. And this one's weird because it cancels out. So we get 550A equals 100A. All right? So we're going to subtract 100A from both sides. So we're going to get 450A equals 0. And then we're going to divide both sides by 450. And A equals 0. So we solved this algebraically, and that was our answer before when we brute forced it. Right? 1007 times 5 is 1035. All right? And that's how this works. All right, so I get that this can be mind-blowing. I get that some of you guys never saw anything like this before. It's actually going back to fundamentals. Theoretically, you learned this in 3rd grade, but it was never really slapped on your faces. Okay? And these problems could actually be really slippery, and that's why they're kind of more advanced. This is really more of a SHSAT 9 question, not a SHSAT 8 question, and it's definitely a Hunter College High School question. And it's probably more for the later on things. It's more at even touchy for the SAT. All right, so all right, I'm going to end this. We're going to do some more of these at some point. I have 1 or 2 more already ready. I didn't know how long this was going to take. I'll keep it simple, but the algebra works the same. And by the way, some of it, this symbolic unknown digit thing, it could also involve addition as well. So it could be something like, and it can involve more than one symbol. So I could have A plus B, C, D equals 5, 6, 7. And you have to solve this algebraically. Okay? It's not going to be as cryptic as this. This is impossible to solve. Actually, technically, it's not. You can get ranges for these numbers just based on this. And we can do it by brute forcing, and we can also do it algebraically. And sometimes what you have to do is solve the 2 things simultaneously. In fact, I have a problem involving something that's not about these digits, where there's some wiggle room in the numbers. What I might do is do that one first, do another stream where I do that one first, and then another kind of problem involving these kind of things with that, just to be demonstrative of what I'm trying to talk about here. All right, anyway, everybody eat your Wheaties, absorb this, and have a great day. Take it easy, people. Peace out.